Hi, I'm Jack and we are the Potential Difference Conductors. So today we're going to be talking about our solution, modular batteries in rail. Trains powered, emissions cowered.
So Ireland actually has the least electrified rail system in all of Europe, with only 10% of Irish rail being able to handle electric trains. That makes rail an enormous greenhouse gas emitter and is hampering Ireland in reaching its climate action goals. Our company provides a solution that is more cost effective and more time efficient than any other solution on the market.
So innovation is seen throughout many sectors. If you Google future cities and sustainability, images like this appear. And what you'll notice straight away is your personal, your family and your small scale transport. So you can see that with the cars, the electric bikes and the shuttle buses. What you are missing is large scale public transport, apologies. So the next step is that. But what is the issue? What's causing the blockages? Why isn't this already included?
So trains, as you know, affordable public transport. They're convenient and they all, currently, almost all, run on diesel. There's a small bit of electrification in Dublin in the Dart. This massive usage of diesel incurs high carbon taxes and massive greenhouse gas emissions, with 144,000 tonnes of carbon being emitted by Irish Rail. 82% of this, scope 1, is from the trains themselves using diesel to drive along the tracks.
So what about the future of Irish Rail? Nations are implementing strict environmental policies, and with the transition to cleaner energy, diesel is rising, and this becomes an economically and financially unsustainable problem in the future. A temporary solution is biodiesel. From our interviews, we know that Irish Rail has a contract to use biofuel, but this only offsets about 90% of carbon emissions. So what about the other 10%? Investing in diesel trains now is a bad investment, considering the global trends are moving towards electrification and decarbonization. Carbon taxes are increasing. This also drives ticket prices up, which reduces the number of passengers and thereby reduces the overall fiscal safety of a company.
So Ireland is set to miss its climate action goals for 2030 and 2050. For 2030, emissions were to reduce by 51%, which is deemed almost impossible at the moment. Therefore, the country is facing high European carbon charges. Fossil fuels are being phased out. Worldwide, the true cost of burning fossil fuels is being experienced through the environment and also through public respiratory health. Diesel engines will soon be obsolete, and we think that Irish Rail can take this opportunity to get ahead of the curve. Finally, we believe that this can offer Irish Rail a fantastic opportunity to become green ambassadors for sustainable transport across the world.
Okay, so how do we solve it? Well, modular batteries. Decarbonisation is costly, and batteries are a faster and more cost-effective solution than overhead electrification. Modularity, our key point. It's a quick swap in, swap out for refueling. The batteries themselves charge quickly. And through solar panels or green power purchasing agreements, where you agree with your electricity supplier that all your electricity comes from renewable sources, you could conceivably have carbon-free rail travel. Lastly, it's an easy transition. Battery storage facilities will still have to be built, but these come at a fraction of the cost of large-scale overhead wiring, which will be discussed again later. So, this is the team. I'm Jack. I'm an energy engineer with experience in the project managing and auditing sectors.
My name is Saul. I'm an energy engineer and I have experience as a design engineer in power systems.
Hi, I'm Sashita. I have a bachelor's in electronics, and I also worked as an electronic engineer.
Hi, I'm Niall. I have a bachelor's in energy engineering and I work in facilities and operations. So if we're looking at post-tender, our outlook is we want to expand our division. So we'll be looking to come in with a financial advisor, planning and law experts, and civil engineers where they're needed.
So why batteries? They store and deliver energy to power basically anything from your smartwatches, phones, and even vehicles. Lithium batteries are being used in electrical vehicles for a number of reasons. They reduce greenhouse gas emissions and dependence on fossil fuels. They're already proven being used in cars all around the world, and they're 20 times less likely to catch on fire when compared to petrol and diesel cars. These batteries in trains could make it far more efficient than the current diesel systems.
So as you pointed out, they're safer and more efficient and less carbon. So have they been tried? They have been tried is the great part. So they've worked across 3 different scenarios. So firstly, Hitachi manufacturer have found 70 kilometers of range up to their batteries. Dart up in Dublin has done 80 kilometers of range, and the Great Western Railway in England has gotten up to 138 kilometers. And the engineers perceive up to 190 plus kilometers is possible.
So then, a deep dive into the economics as promised. So this is a map of Ireland and its train stations. Now, in conjunction with a government study done in England and Irish Rail, we found approximately 4 million per kilometre will be the cost of overhead electrification. For the nearly 2,000 kilometres of rail around Ireland, that comes to 7.776 billion. Our solution, on the other hand, 943 million. Now, this includes the batteries themselves, retrofitting and upgrading carriages on the trains, and also the construction of battery charging stations at all 11 terminal stations and also 30 of the smaller stations, which will be discussed at a later point in the project.
So battery technology is constantly developing. It's becoming more efficient and more economic than fossil fuel systems. Current technology used in electric vehicles at the moment are lithium-ion cells, which have a life of about 300,000 kilometres. But future technologies such as solid-state batteries, which are expected in 2030, are expected to have a lifetime of about 1 million kilometres and are much more energy dense. So this is a video just explaining the situation if a battery system is to be swapped out rather than fast charged for our solution.
This is the modular battery solution that we've decided on. Up here is Dublin and down here is the train station we're pulling into, for example. So train comes from up here, rolls down the tracks, stops here, and as passengers get on and off, battery section of the train, this carriage here, which would be much smaller in real life, detaches, pulls away into the slip road. A new battery comes along from another slip road, rolls onto the track, connects to the train. The train is fully powered and able to pull off again.
So as part of our investigation, we undertook a feasibility study across a number of stations in Ireland to see the available space there was for installing these charging stations. We found that there was an enormous amount of free rail yard space in Ireland and a lot of existing lines that are no longer used. So it was definitely feasible in most cases to install these stations.
So if all the trains were to be converted to electric trains, we would save up to 180,000 tons of carbon dioxide per year. And switching from inefficient diesel vehicle engines to electric motors would save up to 225 million kilowatt hours. Using battery trains would save up to 87% in cost when compared to overhead electrification, and that's why we think our modular battery solution is the next revolution in rail.
Okay, so separately on modular reflection, so kind of our 3 main takeaways as we went through it was firstly the importance of interactivity. So the insights we gained when going out and doing the interviews is invaluable, getting the industry experts' opinions, their own knowledge, and challenges we hadn't thought of, and how they were able to go about them and give us guidance throughout was very helpful. So the design thinking process was new to all 4 of us. We really enjoyed going through it and kind of came away with the main learning points of the lean canvas and developing the persona map, and how critical this was for the rest of the process. And lastly, the preparation. So sharpening the axe for 7 hours and only having to cut for 1 was kind of eye-opening to the design process problem. So you kind of see that middle image was kind of the pathway we found ourselves on at the start. Going in and around the problem, trying to figure out everything, thinking of a solution, going back, redesigning it, getting better and better, and eventually come away with an idea that we were happy with.